Hello everyone. So in this video we are going to learn about mineral and chemical bonds. Alright, so these are the two lesson goals for this video. You should be able to describe the relationship between atoms, elements, and compounds. And you should also be able to describe chemical bonds that we're going to talk about in this video. Alright, so one thing that we have to remember is that minerals are compounds and they are composed of one or more atoms bound together by chemical bonds, okay? And it's very important to understand this concept when we learn about minerals because both the atoms and the chemical bonds themselves that form minerals, they're actually very important because they actually give those minerals specific physical properties, which can be important because they can be diagnostic. It can actually help us to identify those minerals. Okay, and that is the reason why we learn about chemical bonds when we learn about minerals. So let's start with the very basic stuff. I just want to review the basic stuff that we learn in basic chemistry. Let's start with atoms. Okay. So atoms are the ones that make up elements. Okay, when we say elements, this will be a good example for elements, carbon elements. Okay, carbon elements consist of atoms, and atoms are composed of nucleus consisting of protons and neutrons that are surrounded by electrons in electron shells. So for example, I have the nucleus of carbon right here. Let's say that is the nucleus of carbon. And remember that nucleus of carbon will consist of a number of protons and neutrons. So these nucleus consists of protons and neutrons. And outside this nucleus, we will have orbitals of electrons. Okay. And because it has 6 atomic numbers, so therefore it will have 6 electrons, so 2 in the inner part of the orbital, and then I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 electrons that are orbiting the nucleus of carbon. So that's what it looks like. And here are some addition of some definition of the basic concept of atoms, such as atomic number. It is the number of protons in the nucleus or number of electrons in the electron shells, and we're going to take a look at what I mean by electron shells. And the second one is about atomic mass number. It is a number that represents the number of protons and neutrons in the nucleus. Okay, I just want to give you a very basic review of these concepts. So let's take a look at the atomic structure of carbon. Okay, so this is how the atomic structure of carbon looks like. Again, it has a nucleus, and that nucleus consists of both proton and neutron, right? And then right outside of it, we have electrons that are orbiting the nucleus of that atoms. Okay, so here I have 1, 2, 3, 4, 5, 6 electrons, and those number is the same with the atomic number of carbon. Okay, so that's something that I would like to mention here, because the next thing we're going to talk about isotopes and chemical bonds. So first, let's talk about the isotopes. Isotopes are just basically 2 or more atoms with the same atomic number. So it has the same atomic number, but with different atomic mass. Okay, so for example, I have carbon 12, carbon 13, and carbon 14. These are all isotopes of carbon. The only difference between these 3 carbon atoms is that they have different number of neutrons. So for carbon 12, it has 6 protons and 6 neutrons. Here I have 6 and 7 neutrons, and here I have 6 and 8 neutrons. Okay, so if you add this number together, 6 plus 8, 14, 6 plus 7, 13, 6 plus 6, 12. Okay, so the mass are basically different because we have additional neutrons here in this case. Okay, but the atomic number is the same. Okay, which is 6. All right, so that's isotopes, and understanding about isotopes is very important for us because we're going to talk a little bit about carbon dating or absolute dating later during the semester. And when we talk about that, the concept of isotopes become very important. All right, next is let's start talking about chemical bonding. Okay, here's the thing: atoms form chemical bonds to make their outer electron shells more stable. Okay, so here is what I mean by outer electron shell. Right there, that is the outermost electron shell for carbon in this case. Okay, now electron shells, again, it is the space occupied by electrons, and the outermost electrons are called valence electrons. So I have 4 valent electrons for carbon: 1, 2, 3, and then 4 valence electrons. Okay. Um, First electron shell only holds 2 electrons, so 1 and 2. But after that, for most elements or for most atoms, they will need at least 8 electrons to complete their outer shells. Okay, so think about this. By the way, the rule is called the octet rule. So think about this. So all atoms, they do not like to be alone. Okay, they want to make some bonding with other atoms. Okay, now in order to make those bondings, in order to make good bonds, they have some sort of a rule here, and the rule is that the outer part of that electron shell must be occupied by 8 electrons. Okay, that's what makes atoms happy. Okay, and we want to make them happy. Okay, so in this case, carbon, because it only originally has 4 electrons in the outer part of its electron shell, so therefore it needs 4 more, right? Because we need to have 8 electrons. Originally it has only 4. In order to make 8, we need 4 more. Okay, so that's and we're going to talk a little bit about how we're going to get the 4 electrons. Okay, so there are 3 different chemical bonds that I'm going to talk about here in this video. The first one is called the ionic bonds. Second one is covalent bond, and the third one is van der Waals bonds. Okay, now the first one is called ionic bond. Ionic bond occurs when there is an exchange. Okay, that's the key word right there: exchange of electron, and it typically happens between a metal and non-metal. Okay, and it typically happens because there is an attraction between positively charged atoms called cation and with negatively charged atom called anions. Okay, so when you have this positive and negative ions, negative. Okay, they become, they are attracted with each other, and they will create a very strong bond. Okay, and the example for that would be sodium plus chlorine. Okay, so here is sodium. This is the atomic structure for sodium. As you can see here, sodium has 11 electrons because the atomic number is 11. So here, let's just count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons plus the outermost part right here, 1. That one lonely electron in the outermost part of sodium. Okay, so sodium will, in order to make it more stable, rather than gaining 7 more electrons, it's just a lot easier for sodium to just give up its 1 electron. Okay, and that's what's gonna do when it meets with chlorine. Okay, because chlorine has 17 electrons. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, and 17 right here. So I have originally 17 electrons, and I have 7 electrons in the outermost part, in the outermost electron shell of chlorine. So it's just a lot easier for chlorine to just receive 1 electron to make it more stable. So here I have sodium that wants to give 1 electron, and chlorine wants to receive 1 electron, and both will be happy. Okay, so there will be some exchange here. Sodium will lose its 1 electron and become positively charged, and chlorine will receive 1 electron from sodium, and it will become negatively charged. And when that happens, attraction occurs, and it will create a compound called sodium chloride. Okay, and that is, my friend, is an example of ionic bond when there is an exchange of electron. The second one is called covalent bond. Covalent bond occurs when electrons are shared. Okay, when they are shared between atoms, and they typically happens among non-metal elements and creates strong bond. In fact, very, very strong bond. Okay, the example would be carbon bonds in diamond. Okay, so here is again the kind of the structure of carbon arrangements within diamonds. And as we have discussed earlier, that carbon in the outermost part of its electron shell, it only has 4 electrons. So for example, here, this middle carbon here, I have it has 1, 2, 3, and 4 electrons. In order to make it stable, it requires 4 more. So what it does is that it shared its its electron with the other carbon atoms. So here it has 2, 4, 6, and 8. Now it actually has 8 electrons by sharing, the electrons with their nearby and adjacent carbon atoms. Okay, so each of these bond right here, it is called the covalent bonds. Okay, covalent actually means means working together, and valent refers to the valence electrons in the outermost part of the electron shell of a carbon of an atom. Okay. And the third, before we go to the third one, is that this is again an example of covalent bonds of carbon atoms in diamonds. And each of these carbon atoms, they create a very strong bond, a very strong covalent bond. And that is the reason why diamonds becomes one of the most, or one of the hardest minerals on Earth. Okay, because of these covalent bonds that create a nice 3D framework of carbons. Now, unlike diamonds, graphite, which is something that, which is a mineral that also consists of carbon, right? We know that both graphite and diamonds, they both consist of 100% carbon, but we know that they exhibit a very different physical properties. Graphite is in fact very soft, right? Unlike diamonds. Now the reason for that is because it does have van der Waals bonds. Okay, so let's take a look at the arrangements of carbon in graphite. It actually does have strong bonds here between carbon atoms. But the thing here is that in graphite, these carbon bonds, they come in layers. So here I have 1 layer, 2 layer, and 3 layers. Okay, and these layers are connected by these vertical bars here. These vertical bars, they actually represent weak bonds of carbons, which is called the van der Waals bond. Okay, so that is an example of van der Waals bonds here. So van der Waals bonds are basically weak bonds that, that connect between layers of carbons in graphites. Okay, and that actually the one that allows us to write on a paper, on a piece of paper, because we know that graphite is used in the tip of pencil lead. So we actually, when we apply pressure onto a piece of paper, it will just give some, leave some streaks on the paper, allowing us to write with graphite. And yeah, so that is the reason why graphite is so weak, and we can use it to write on a piece of paper. So I think that's all that I would like to say in this video. And again, if you do have questions, let me know like usual. And I'll see you again in the next video. Bye bye now.